Hello students, this is Sanjay sir from the Mathswell YouTube channel. Today we are going to see the continued part of the number system. Okay, that is the rational and irrational numbers here. So in the last video we have seen the denseness property of the rational number. Okay, so I just revised quickly what was the denseness property of the rational number. It was like this: between any two rational numbers x and y, there is always a rational number given by half of x plus y, such that it will lie between x and y. And we see that the repeated application of this property, this theorem, we will conclude that there are infinitely many such rational numbers lying between the two rational numbers. This we have seen in the last video. Okay, so now we are going to solve some examples. Okay, so just see here. So we need to represent the following numbers on the number line. So how it can be represented, just see here. So the first example given is 3 by 7. So to represent 3 by 7 on the number line, as we have seen previously also, you can have these examples. So as 3 by 7 is lying between 0 and 1, so we divide the unit length 1 in 7 equal parts, and the third point among those 7 points will give us the required rational number 3 by 7, right? So when we divide the unit length between 0 and 1 in 7 equal parts, then the third part out of the 7 will give us the required rational number 3 by 7. Okay, similarly, if the number is given 16 by 5, to represent 16 by 5 on the rational number on the number line, the very first step is to check between which two rational numbers this 16 by 5 lies, between which two integers we can say lies, between which two integers this given number lies, that we need to check first. Okay, so here if you see 16 by 5 can also be written as 3 1 by 5. Okay, it is a mixed fraction, means it will lie between 3 and 4. So 3 and half, 3 and 1 by 5 means it lies between, it is greater than 3 and less than 4, obviously. So again we need to divide a unit length 3 to 4. Clear? So that 3 to 4 should be divided in 5 equal parts, and that first part will represent the required number, that is 3 1 by 5, or we can say 16 by 5 is the required rational number on the number line. Clear? I hope this part is clear, how to represent the rational number on number line. Similarly, you can see this example minus 3 1 by 6. So how this minus 3 by 1 by 6 can be represented on the number line? You can see here again, since this 3 1 by 6, it should definitely, it is negative number, so it should definitely lie between minus 3 and 4, minus 4 and minus 3. Okay, it is greater than minus 4 and less than minus 3. So we can see that since minus 3 1 by 6 lies between minus 4 and minus 3, so again that unit length minus 4 and minus 3, between minus 4 and minus 3, should be divided in 6 equal parts, and the first part will represent the given rational number minus 3 1 by 6. That is 6 are 18 plus 1 19 by 6 will be the required rational number that is represented on the number line. So students, you can just practice such type of example, how to represent the rational number on the number line. Now let's move ahead. So in this video today we are going to see these examples. Find the rational number between 3 by 5 and 7 by 9. So that is the example on the denseness property. Okay, so in the denseness property we have seen that between any two rational number we have one more rational number which is given by half of x plus y. Okay, if x and y are the given two rational numbers, then half of x plus y can be obtained. So here we are going to find only one rational number between the given two rational numbers, so which is given by half of x plus y. So here 3 by 5 and 7 by 9 are the given two rational numbers, so they are x and y. So we can find a rational number between these two by using that denseness property given by half of x plus y. So it is half of x is 3 by 5, y is 7 by 9. So half of 3 9s are 27 plus 7 5s are 35. So 27 plus 35 will give us 62, 62 by 45, and half is multiplied to it. So when we multiply half to 62 by 45, so the 62 and 2 can be simplified. So 31 to the 62, so it gives us 31 upon 45. So you can say that 31 upon 45 is the required rational number between 3 by 5 and 7 by 9. Everyone understood this? Yes. So it's very simple. Just use a simple formula of half of x plus y, or you can just add two rational numbers and divide it by 2 will give us the required number between the given two rational numbers. Let's move ahead. So here you are asked to find three rational numbers between the 1 by 3 and 2 by 5. Okay, the numbers are given as 1 by 3 and 2 by 5. So how it can be calculated? Again, simply we are applying the denseness property here, denseness theorem here. Okay, what it is again? Half of x plus y. So x is 1 by 3 and y is 2 by 5. Just taking the half of the sum of these two will give us the first number between 1 by 3 and 2 by 5. So if you see here, we come to know that 11 by 30 is the first rational number between 1 by 3 and 2 by 5. Now to get the second rational number between these two, either you can keep this x fixed, that is the first rational number will be kept fixed, and just keep changing this second rational number. As here we have taken between x and y 1 by 3 and 2 by 5. While finding the second rational number between these two, we consider the a as x as 1 by 3 and y as 11 by 30, and applying the same property, denseness property here, we can have the second rational number between the given two rational numbers. So since 1 by 3 is less than 11 by 30, we can find half of 1 by 3 plus 11 by 30 as a number between 1 by 3 and 11 by 30. Okay, so just simplifying here, we come to know that the second rational number between the given two rational number is 63 and 180. Okay, so now we have the third rational number between the given two rational numbers. Again, I keep 1 by 3 fixed and as a x, and take y as 63 by 180. Okay, so x is 1 by 3, y is 63 by 180. Again, applying the same result, 1 by 2 x plus y, it will give us 1 by 2 times 1 by 3 plus 63 by 180 will give us as a number 369 by 1080 as a third rational number between the given two rational number. So in this way we can have the three rational numbers between the given two rational numbers are 11 by 30, 63 by 180, 369 by 1080. So students, as I have keep the value of x constant and change the values of y. I have taken y as a new rational number we are having. You can do in this way also by keeping y fixed and go on changing x. So that way also we have the rational numbers between the given two rational number, but the numbers may change. Numbers may change. Answer may be different for different students. Okay, when we take the keep the first x constant, x fixed, and go on changing the y values, the numbers will different. When we keep y fixed and go on changing x, the numbers will be different. They will not be same. So in such type of example, your answers may differ. They may not be equal always. Okay, so this is the way to get the three rational number between the given rational numbers, given two rational numbers. So we have one more method of finding the rational numbers between the given two rational numbers. How it is, let's see in brief. Okay, and then we will stop. So what we have here, find 10 rational numbers between 1 by 2 and 3 by 5. So see students, we have 10 rational numbers between the given two rational numbers. So how it will be obtained? So in such case, that method, that denseness property will be applicable, but it will take more time to calculate. Okay, so here we have some shortcut method, some different method known as a shortcut method. We just call it as a shortcut method. So what it is, just see here. So in this case, what we do, we just here the number is not only 1 by 2, but it is minus 1 by 2. It has some printing mistake. So here it is not a half only, but it is minus half. Okay, so consider it as a minus half. So here minus half can be returned. So see here the denominators are 2 and 5. So in such case, we just see the denominators 2 and denominators and take their LCM. So here the denominators are 2 and 5, and the LCM of 2 and 5 is 10, we know. Okay, so after getting the LCM, what we need to do, we need to convert the denominators of both the given rational numbers to the LCM by multiplying and dividing by some suitable number to the given fraction. Okay, so for minus 1 by 2, to convert the denominator 2 to 10, we need to multiply it by 5. So we need to multiply and divide by 5 to the given rational number, so that we can have it as minus 5 by 10. Similarly, the second rational number is 3 by 5. So to make that denominator 5 to 10, we need to multiply it by 2. So multiply and divide by 2 to the given rational number. So it gives us 6 by 10. So once you got such rational numbers with equal denominators, the remaining part is very easy. So just go on adding 1 to the numerator will give us the required rational numbers between the given two rational numbers. So like if we add 1 to the minus 5 by 10, what this gives us in the numerator only, not in denominator. We just need to add 1 to the numerator. Keep the denominator fixed as it is. No need to change the denominator. Will gives us the required rational number between the given two rational numbers. So minus 5 by 10, if we add 1 to minus 5, will give us minus 4. If we add minus 1 to minus 4, will give us minus 3. If we add 1 to minus 3, will give us minus 2, and so on. So this gives us the 10 rational numbers. Which are those? They are minus 4 by 10, minus 3 by 10, minus 2 by 10, minus 1 by 10, then 0 by 10, means it is 0 only, 1 by 10, 2 by 10, 3 by 10, 4 by 10, and finally 5 by 10. Okay, and finally we have 6 by 10. So here we can add one more number, one more rational number after the 4 by 10 as 5 by 10. Okay, so this gives us the 10 rational numbers between the given two rational numbers. Dear students, so in this way we can find the infinitely many rational numbers between the given two rational numbers. So students, hope you have understood the concepts we have seen today. So with this example we will stop today. So we will continue the remaining part of this topic in the next video. So till then, just practice this example. If you have any doubt, you can just put your doubts on my WhatsApp group. The contact details are given in the description box. Okay, and don't forget to share and subscribe this channel, and share this video with the needy students, the needy friends with you. Thank you. See you in the next video. Thank you.